Good morning, friends. Today we'll see the laboratory practice 3 and assignment number 1, that is implementation of conflation algorithm. Before we move to the actual conflation algorithm, first of all, we should understand the iron black box model. What sort of processing happens inside this particular book. So here we are actually processing the document, and our ultimate goal is to generate the document representative of that particular document. So document may be a large enough document where number of lines are inside that particular document. And we need to create a document representative which contains the keywords from that particular document, which is called as a document representative. So here in our black box model, we are having document under consideration, and we are having query on that particular document, searching for certain keywords, and finally we are generating the results that is termed as a document representative. Now in detail about what actually there inside this particular IR black box. So here just see document. So representation of document is there. We are representing the query, and we are filing that particular on the document, and we are generating the result. So searching is happening inside this particular this actually area is called as a process. So searching is happening inside this particular box, and index is also actually happening inside this particular box. And after such type of processing, we are in position to generate the result in terms of the document result. Here we are giving the feedback again to the query. Okay? So that feedback is required if your document is whatever the keywords or say document representative that you are generated is not that much relevant to the expected query outcome, then we need to again refine this particular query by considering the feedback from this particular result. So these are different components, system components of the information retrieval. Like text operations are there, that means how the index work, that is called as the tokens after removing the stop words and the stemming. So we'll see details what is stop word removal and stemming. Then indexing, that is one of the important point in this particular area, that is construct an index over two document pointers. Searching is another one of the important aspects. It's all been happening inside that particular processor, this section, processor, rectangular box. So since searching retrieves document that contain a given query token from the inverted index. Then ranking scores all returned documents according to the relevance matrix. Traditional text processing here, stopword removal, stemming, and other processing tasks for text like digits, hyperlink, punctuation, case operators that we are considering. This is the logical view of the document. So here your document under consideration, you are extracting the structure of it. Then you are working on the action passing of that. Then you come to the full text is in front of you. Then you go for the stopword removal. Then you work on the noun groups. Then you go for the stemming, and finally manual indexing of that particular document, and you are generating the document representation. So this is the document representation view, that is also called as a logical view of the doc. So index terms and all these things that we'll see in detail in the conflation algorithm in the concept repeating. What do you mean by stopwords removals? What do you mean by stopwords actually? Stopwords, or these are also called as the flip words. These are some of the insignificant words which occurs more frequently in that particular document or in that particular text. So the stopwords are frequently occurring an insignificant word in a language that help construct sentence but do not represent any content of your document. Right? So these such words you are supposed to identify from your document. For example, the, this, that. These are nothing but the two stop words, right? Those you are supposed to remove. Because like to, for, by, at, with. These are another set of stop words. The conjunctions like and, or, so. These are again called as the stop words. Pronouns like he, who, he, she. These are also comes under this particular stop word. So your duty is to remove that particular stop. So there is a list of, you can see that the vocabulary of stop code that you are supposed to maintain. The next, that is stemming. So stemming is the process for reducing inflected or sometimes derived words to their stem or to a base word or root word. For example, I'm just giving the example like so engineering. If that is the word, ing is the suffix over there, right? So that you are supposed to stem that particular ing, and then you have to work on that particular original work and consider the root word of that particular engineering. For example, here you can say now say books. So here that means when I was saying this index book dash is like books, works, do, does, did, doing, right? So such type of things you are supposed to consider. That means word may have various forms in different situations, right? That you are supposed to consider. So stem is a portion of a word that is left after removing its suffix. So that is called when you strip the suffix, or so whatever remains, that is called as a stem. So for example, if I am saying compute, computer, computing, if I am working on this particular word and I am applying suffix stripping here, so I will remain with the stem, that is the compute. This compute is the stem. Then another say walks, walking, walker. Walk is the stem that coming out of that particular suffix stripping. Suffix removal here is based on a set of rules to remove endings like ing, ed, s, like this. Okay? So you are supposed to remove such type of suffixes. Now focus on our assignment number 1 implementation. So here what we are supposed we have to actually do here. So here we have to consider the input text file. Say .txt file where you can have words, right? Different words you are supposed to include in that particular words or text or sentences you have to include in inside that particular text, and then you need to remove that particular text. Now here consider that here, say for example my text file is like drama does not travel as well as poetry or the novel. India has a growing peace, or say constituency, like this step of text you are supposed to include inside that particular text. Now here after that you have to apply the conflation algorithm step. There are three prominent steps in the conflation algorithm. First, stop word removal, that is remove stop word. Second, that is suffix stripping, that is called as the remove suffixes. And third, eliminate redundant steps, right? So those eliminate redundant steps you have to implement it. And finally you have calculated the term weight and so on. So suppose this is your document file or text file. So here you are removing the stop word. So you can identify the stop word like does, not, as, right, or the. So stop word list you are supposed to remove from that particular word, right? Then you have to apply, say for example, the suffixes you have to identify. You have to remove the suffixes from that particular this word like growing. So you have to remove this ing and so on. So here term weight calculation like methods term frequency. So how many after processing the document you remain with the document representative contains the keywords. So here you are supposed to find out the frequency of occurrence of that particular keyword inside that particular document. So you can find out the term frequency accordingly. You can go for the probabilistic indexing. So here n is number of occurrence of the term t, x is the mean of number of occurrences of the t, and so on. So these are the formulas to find out the term weight calculation.